I am now back to show you the solution for test 3 problems. Show complete solutions. Item number 2. Solve for the equivalent resistance of the resistor network below. 15 points. The resistor network is given as follows. You have your R1, R2, R3, R4, R5, R6, R7, and R8 with the following values. R1 is 30 ohms, R2 is 10 ohms, R3 is 15 ohms, R4 is 10 ohms, R5 is 10 ohms, R6 is 30 ohms, R7 is 20 ohms, R8 is 30 ohms. R3, R6, and R8 are in parallel. Using the formula for parallel connection, R3 is parallel with R6 and is parallel with R8. So you have the formula 1 over R3 plus 1 over R6 plus 1 over R8, negative 1. 1 over R3, R3 is 15 ohms. 1 over R6, R6 is 30 ohms. 1 over R8, R8 is 30 ohms. Using your calculator, you will get 15 over 2 ohms or approximately 7.5 ohms. Let us proceed to the other part of the circuit. Since R4 and R5 are in series, using the equation to compute for series connected resistors, R4 is in series with R5. R4, which is 10 ohms, plus R5, which is also 10 ohms. Adding the two, you have 20 ohms. Since R4 and R5 were combined, giving us 20 ohms, therefore R2 is parallel with the series combination of R4 and R5 and R7. Using the same equation for parallel connection, you have R2 is in parallel with the series combination of R4 and R5, which is 20, and is also parallel with R7. So 1 over R2, R2 is 10 ohms, plus 1 over 20, plus 1 over R7. Your R7 is 20 ohms. Using your calculator, you have 5 ohms. Therefore, your R equivalent is now R1 plus 5 ohms plus 15 over 2 ohms. It gives you 42.5 ohms.